Okay, question 14. A child in a bumper car travelling at 7 metres per second collides with a stationary bumper car ahead of him. The diagram shows the bumper cars before the collision. Assume the bumper cars move off together after the collision. Calculate the velocity of the bumper cars after the collision. So this one has an initial velocity of 0. So we're going to find the total momentum before and put it equal to the total momentum after. Afterwards, it says that the two bumper cars move off together, so they both got the same velocity v. Mass of 300 and a mass of 250. So the total momentum before m1 u1 plus m2 u2 is equal to m1 plus m2 times v, because they joined together. So I have here 300 times 7 plus 0 is equal to 300 plus 250 times v. So v is equal to 300 times 7 over 300 plus 250. 300 times 7 divided by 300 plus 250. 3.81 meters per second. Okay, so then it says that the cars come to rest after travelling 1.3 metres. The cars come to rest. Calculate the magnitude of the frictional force between the cars and the floor. So you can do this using F equals ma and initial velocities and final velocities, but I'm going to do it with energy actually here, because what's going on is that the friction is doing work. The work done by that friction must be equal to the loss of any kinetic energy. So we have friction times 1.3 must equal a half mv squared. So I've got F is equal to a half mv squared over 1.3, which is a half times, right, the total mass over here is 300 plus 250, and the speed was 3.81 squared, all divided by 1.3. So let's do that. 0.5 times 300 plus 250 times 3.81 squared divided by 1.3, giving me 3,070 newtons. State one assumption you have made in order to carry out your calculations. Well, we have assumed that there is, it says calculation in part A, so it's this part we're interested in. We have assumed, remember, conservation of momentum, that you are assuming that there are no external forces, e.g. friction, during the collision. You have to assume that for conservation of momentum. So this is asking about this bit. Okay, there we go.